Hi, I'm John Elliott. I'm a consultant. I work for JScrambler as their security advisor. And surprisingly, I'm not here to talk about requirements 6.4.3 and 11.6.1 about e-commerce skimming, which seems to be all I've talked about for the past 5 or 6 years. I'm going to talk about more interesting things today. But don't worry, because my colleague Pedro is going to talk about 6.4.3 and how e-commerce skimming can attack iframes in just a few sessions' time. So don't worry that you're not going to get your fill of 6.4.3 today. Okay. Any of you here in 2015 when John Nance, well, not here, in Nice in 2015, when John Nance started talked about aviation and cybersecurity? John Nance is an amazing guy. He writes great books. And he basically worked out in the 1970s in America, lots of airplanes kept falling out of the sky. And he worked out this was a bad thing and we should work out how to make it not happen. So he actually started a lot of the safety engineering culture. Were any of you here in 2017? Actually here in this place where Jeff Skiles spoke. Again, aviation and cybersecurity. Jeff was the first officer on the plane that landed in the Hudson. You've all seen the film Sully? Right. He was the other guy. We had him, obviously, because he was loads cheaper than Sully. Right? But he did a great presentation about how aviation security works. And so really, I'm really just like extending on those two guys. When I saw John Nance speak in 2015, I went out and I bought his book, which he published in the 70s, and I thought, we could learn so much about cybersecurity from aviation. And then something weird happened to my career. It actually happened in Nice, was that I met someone at the community meeting who went, John, could you do some 3 days consultancy for me? And it's like, oh, I guess so. And that ended up to 5 years of my career working for an airline. So I took EasyJet, which is the best airline in Europe, of course. I took EasyJet through PCI DSS compliance, but I ended up being the head of information security, a job I'm singly unsuited for, I discovered while doing it. But I spent a load of time working with our safety colleagues and learning how aviation safety worked, because I sat on the safety board and the safety committee and all sorts of things. In fact, we even renamed our team from information security to digital safety, to emphasize that we were part of the same mission of keeping our passengers and our crew safe. So I learned loads about it. And I want to share something with you about how aviation does safety and how we can learn some really simple stuff in cybersecurity. Is that okay? Great. So I used to do... If you've been coming to these, this is one of my favorite slides. It says that all controls, I'm going to use the word controls, but like controls requirement, yeah? All controls fail over a certain period of time. They just naturally, like entropy takes over, they naturally decline. And when I worked for Visa, people used to say, oh, why do we have to have a QSA assessment? They're really expensive. All QSAs are really annoying, which of course they're not, speaking as an ex-QSA. Why do we do this every year just to keep Visa happy or just to keep the brand happy? And the answer is this, that it's a security control. Because all your controls, all your requirements degrade over time. They're not as good as you think they are. And the great advantage of an assessor, whether it's an ISA or a QSA, coming in and looking at it, is they find the controls that are failing. And you can get them back up to the stage where they're above that attack threshold, where they're above the level where the control is not effective to stop the attacker being able to do the thing that the attacker wants to do. So that's why we have annual assessments. It's an assurance control. It's not just to keep QSAs in business, okay? So what's happened in the past 10 or 15 years, though, is the cyber crime market has changed massively. You see, it used to be you needed someone to break into an organized system, and then somebody else in the organization to work out how to monetize it, which, of course, in our case is to steal the cardholder data and then to sell it, and then actually to do that work and then to launder the money. And so we used to have sort of quite large criminal gangs doing this. What's happened over the past, say, 10 years is we've got this vertical disintegration where if I'm just good at breaking into places, but I don't want to work out how to monetize it, I don't want to do money laundering or anything else like that, I can just sell my access to somebody else who can and does want to do that. And what that meant is the number of attackers we face has massively increased, and also the attackers' persistence and capability has also increased, which means that attack threshold is much higher. And if I had a laser pointer, I'd point it at the thing that says, look where the purple line is now. Our controls don't need to degrade much now before they become ineffective. So we have to work out how to address that. This is because the world has changed. And in my time, I've read lots of forensic reports and lots of pen test reports, and you see stuff like this. You see things like, well, the firewall was incorrectly configured, or the server that was attacked was the one that was not patched. Like, no shit, right? Oh, sorry. We took advantage of a misconfiguration. Of course you did, pen tester. That's what you do. Or the system we attacked was the one that didn't have the application sandbox. Then when you go and talk to IT, they say, well, yeah, we knew that server wasn't patched. Or things like, yeah, we were going to fix that next week. Or Dave was working on it. Yeah, so we know all these things. We know that we often in a situation where we know things are not as great as we want them to be, but we still have problems. And so if we look at why controls fail, controls fail for two reasons. There's what I call natural entropy and I'm sure you've all seen these in your organizations, like it wasn't fully implemented when we implemented it in the first place. Sometimes it doesn't do what you want. It was misconfigured. No one updated it. Somebody removed it temporarily. You've never heard this, have you? Someone removed it temporarily to stop because something stopped working and we needed to get it working again. Or even nowadays, the person who understood that product, they left and no one else could sort of work out how it worked. And then when we get change in our organizations, we end up with controls that are not on things that we expect to have controls on because it wasn't implemented, or a user removed it, or we added new systems to scope and no one told us that it was in scope, so we didn't put the control on it. Or it was removed to make something work again. Or once I saw this, like, oh, we forgot to relicense it, so it stopped getting updates, so it didn't stop the malware. And this is all really common in our industry, isn't it? But it's not common in aviation because aviation doesn't do safety. Aviation is safe. You don't have signs that say, we do safety. You want your airline to be safe, don't you? And the reason that aviation worked out how to do this back in the 70s, largely down to that book that John Nance wrote, was that we realized that humans are fallible. Like, we're all humans. We all make mistakes, don't we? Like, we're all human, fallible people. And so what John Nance worked out was that we need to address the fact that humans are fallible. So you know something that humans are not? Humans are not the weakest link. They're not the strongest link. They're just humans. In aviation, there's loads of humans. Like a human designed the aeroplane. A human largely built the aeroplane. A human flies the aeroplane. A human gets into the tug that pushes the aeroplane back. Right? Everything to do with aviation, there are humans involved. We're all fallible. We're all going to make genuine errors at some stage. And so what safety-critical industries like aviation worked out is that you have to do something because humans will make mistakes. So number one, you assume that mistakes are going to happen. So do we engineer fallibility out? Do we compensate for it? Do we reduce it? And how do we learn lessons? And I'm going to quickly run through how aviation does this and then draw some parallels with cybersecurity. So first of all, how do we make it so that a human error doesn't affect something? So if a human might make an error, how do we make it so that if the human is fallible and makes an error, nothing bad happens? I'll give you a couple of examples of really common things in aviation. The first is like an electronic tool chest. An aircraft hangar is a bit like a car mechanic's, right? Just a bit big, all right, a lot bigger, okay? At EasyJet, half our office was office, and the back half of the office was a hangar. It was the only place when the fire alarm went off that you actually went out really quickly because there's an aeroplane there with maybe some gas in its tanks. And we used to look out over it. It's amazing to watch. And there are lots of tools you use, like wrenches and spanners and stuff like that. And they all go in a toolbox. You know, like those big red things you see on yeah, okay, you know what I'm talking about. Apart from the ones in aviation who are electronic, they can sense when all the tools are in the boxes. Because one of the big things that caused accidents with airplanes is leaving tools in the engine because it breaks the engine, or you leave tools in anywhere. It pierce the hull, and that's really a bad thing if you have a hull piercing, or it can hit some cabling and it affects the control surfaces. And so the rule is like the airplane doesn't leave the hangar until the toolbox says it's okay for the airplane to leave the hangar. In fact, there are some hangars, and I think ours was one of them, where if the toolbox isn't say it's okay, the hangar doors won't even open. So you engineer safety into the process, because as a human, we might leave a spanner there. So you can't rely on that happening. The other thing is stall control. If you pull the joystick, the yoke or the joystick up too quickly, the aeroplane will stall. Not like when our car stalls, but it doesn't have enough lift, and so it falls out the sky, which is generally a bad thing if you're an airline, if your airplanes fall out of the sky. And so if the pilots do that by accident, if they make an error, the aeroplane itself will adjust and push the nose down again. So that's the first thing. What about in InfoSec? How do we do that? How can we engineer? So if we've got a thing that a human might make a mistake, because we will, how do we make it so that the human error doesn't affect anything? And I've got some examples of things we do now, but we might not do everywhere. We might think, oh, we haven't got that turned on there. So think about things when you look at controls, like can we make it so that human error doesn't affect the control, like software auto-update, rather than relying on someone to go and update the software. Like MFA, because humans naturally will occasionally get tricked by phishers, whose job it is to trick humans, to give away their username and password, in which case we give them a token. Software signing, and anything like that where we can engineer a solution so we take away the probability of a human making a mistake. So that's the first thing that I would always concentrate on. The second thing is we then try and compensate for fallibility, and there are three areas: in business as usual, in rare events, and in assurance checks. And so can we catch a human error before it has an effect? That's what we're trying to do, because we know humans make errors because we're all human and we're all fallible. So the first thing is in business as usual operations. How do we help humans not make mistakes? The first is the airline industry is massively into checklists. So when you walk on the airplane and you look left and the pilot's like doing something, they're completing big checklists. It's like, have you identified which airport you're flying to? Do you have enough fuel to get there? Right? Have you identified the airport that you could go to if that airport was closed? Do you have enough fuel to get there? Right? And so there's a checklist that they just go through. And this is actually, it used to be a bit of paper. Now it's actually built into the aeroplane computer itself. It's like, I've done this, I've done this. Have you done a walk around? The pilot has to get out, put his high-vis jacket on, walk around and look at the plane, and make sure that in the last flight, nothing hit the plane. Like the little sensors haven't been damaged or anything like that. So the first thing is checklists. That's a really massive thing. We're terrible at doing checklists in other industries. And John Nance was arguing that one of his books is called Why Hospitals Should Fly, and it was to introduce checklists into medicine. The second thing you'll all have heard is, you've all heard doors to automatic and cross-check, or doors to manual and cross-check. Automatic or manual depends when you open the door, whether the emergency slide pops out the bottom, right? So if it's automatic, you open the door, the slide comes out. Great, because if you have an emergency, you want to be able to evacuate the plane in 90 seconds. Like all those planes can be evacuated in 90 seconds. The crew practice it. It's an absolutely wonderful thing to watch. But what you don't want is to be running down the runway without that turned on, because you might have a fire in an engine and need to evacuate. And also you don't want to open the door and have the slide pop out when you're at the gate, because it's really embarrassing. And secondly, your aeroplane's out of commission for 3 days, because it has to go to a maintenance hangar and have I was going to say, fold the slide up and push it back in, but no, you put a new slide in there, okay? So, but the crew do it 6 or 7 times a day. And you know when you do something repetitively, like you're not very good at it because you forget you might do it? Was it this flight or that flight when I did that? So the doors to automatic and cross-check is one crew member always checks another crew member's work, and then they all phone it into the head cabin crew that says all the doors are automatic or all the doors are manual. So that's a really good thing. And another good example is, you'll see this quite a lot if you sit on the left of the aeroplane, is when the tug is pushing the aeroplane back. We call it a tug, but it pushes. So the thing that pushes the aeroplane back from the gate, the big sort of diesel or some of them are electric now, but they steer for the pilot, so the pilot's not steering. So you have to disengage the steering from the pilot. And there's something called the steering bypass pin. It's really important it gets taken out before the plane goes, because otherwise the pilot won't be able to steer the aeroplane and it will veer off the side of the runway and it'll be really embarrassing again. And so you will see something like this. If you look out the left of the aeroplane, you'll see the other tug operator, the guy who's been talking to the pilot, holding out like this with a big streamer on it, the pin, and the pilot marks on his checklist the steering pin has been removed, so he's safe to drive the aeroplane himself. And so in information security, how can we do that? Well, we can have checklists and we can have dual control. We don't do this enough. But where you have things where you notice human errors have an effect, and a really good one is starters, movers, levers. In levers, you need to get their device, their MFA token, disable their account. With a lot of SaaS applications, you might need to disable multiple accounts. And therefore, we've got checklists, and there's a good place for a checklist. So checklists in information security could make a big difference to that. And in dual control, where you've got one person checking someone else's, we do a lot of that in key management. But we can also do that in things like in business email. When a supplier says, oh, I've changed my bank account, that's a really fairly common business email compromise. Then get somebody else to check it. So anything. Also, things like addition of admin privileges, removal of admin privileges, you could get somebody else to check that work, because that would be a serious thing if a human made a human error. The second thing is, how do we catch human errors before they have an effect in rare events? Now, a double-engine bird strike is almost an improbable event. I know of 2 of them that have ever happened. This was the famous one where Sully managed to glide the plane. But when you have a single engine failure, it's quite common. And the pilot, so the first thing is there's a checklist that, okay, an engine's gone out. So here's a checklist of what we're going to do. We're going to try and shut down the engine and then restart it. We're going to we're going to radio air traffic control and declare the fact we've lost an engine. We're going to ask where our nearest airport is. We can land if we're not happy continuing. All sorts of things. But there's a checklist. The pilot monitoring isn't thinking, oh, I wonder what I should do now we've lost an engine. They're following a checklist. The other thing is the pilot that's still flying has been rehearsing flying on one engine a lot. Not because we put them up there and turn the engine off, but on a simulator, right? It's a very common thing that every time they go in the simulator, they learn to fly on one engine, because an engine might fail, and you've only got 2 nowadays on most aeroplanes. And so the plans are rehearsed and the checklists are in place. And in information security, we've got an incident response plan where we can do that, okay? And so we've got that incident response plan. So that's our checklist. So when we're under cognitive load of an incident, where we're more likely to be fallible, we don't have to think as much. We can follow the plan and the checklist. But the most important thing, and I know we all think this is a bit of a not very good requirement in DSS, that we have to test our incident response plan annually. But there's a reason for it, is that it becomes something that people get used to doing, like a pilot flying on one engine. And feel free to steal this when you're talking to your executives about why you have to practice your incident response plan. It's just like somebody getting in a simulator flying with one engine. You hope you never need to use it, but the more you practice it, the more it works really well. And then the third thing that the airline industry does is they do checks. So you'll have a senior crew member fly with the whole crew and check they're following the procedure. You'll have a senior pilot, sit on the jump seat behind the 2 pilots, checking they're following their procedures. And this is for 2 reasons. One is to check they're following their procedures. 2 is to check the procedures are still valid and it still helps the way that the organization is working. Because the procedure might need to change. Something might have changed on an airport or on the airline, or the way that something happens, of like, actually that checklist is not valid anymore. People are not following it. They've got a workaround. Finding workarounds is a good thing. And we can do that because we can do prioritized control testing in information security. There's quite a lot in I don't expect you to read it. These are all the ones that are in DSS where there is a scheduled thing that you have to do. There's probably, I'm not going to count, there's probably 20 of them. Whenever I consult with people like, how do I get PCI DSS compliant, I say, getting compliant is the problem. Staying compliant is the really important thing, and that's the hardest thing. So I have a document like this, which for every single DSS requirement, we're going to do an assurance check sometime throughout the year. And we're going to find how many non-conformances there were, and we're going to try and fix the non-conformances, but also make sure that the time to the next assurance check we monitor. And then for every single requirement, I'm going to say how frequently we're going to do a quick control check. This can be a 15-minute or a 10-minute job of like just going and saying, okay, I want to make sure that this thing is working, or I want to make sure that the developer software training is on track. So I'm doing a control check. This might take 2 or 3 hours a week of somebody just checking a DSS control. The ones that have got the most security effect, we do check regularly. The ones that have got a lower security effect, we check occasionally. And this doesn't take a lot of time, but when you get to your annual assessment, we're not relying on the QSA pushing those controls back into good nature. Those controls are in good nature because we're checking them regularly. And if you're thinking, because I bet you are thinking, how do you know which controls to check more frequently than others? Remember the prioritized approach you used when you got PCI DSS compliant? Well, that lists the most important controls first. So I check those more regularly than the milestone 2 and the milestone 3, so I use that. Okay, and then the final thing in the how do we improve human performance, not the final thing improving human performance is like how do we reduce fallibility? And that is we can have mandatory training. In the airline, the pilots have to do retraining. They go in the simulator on a regular basis. They're evaluated because they always fly in pairs, they're evaluated by the other pilot. And they're only limited to how many hours they can fly because we become more fallible the more tired we get. I bet we're all quite fallible today because 3 days at this conference is like, whew, man, right? But pilots and crew can only fly for a certain number of hours, then they have to rest. They can only fly a certain number of time in a certain number of weeks. So you don't have tired pilots, which means you have less potential for fallibility to happen. Can we do that in information security? Yeah, we've got mandatory training in DSS, but I always think we should train our IT people more. It's not a requirement in DSS, but we should train the whole of the IT team about how they're part of the information security or the digital safety team. We should do more purple team exercises which train our red team. And we should manage stress and burnout. Whenever I read LinkedIn now, there's a lot about stress and burnout in our industry, isn't there? Stress and burnout for us is the same as tiredness for pilots. And we are more likely to make poor decisions, we're more likely to be fallible when we're stressed and burned out. I'm slightly over time, but I think I can steal a little more time. So I'm nearly done. Because the last thing we do is like, how can we, when an error happens in aviation, there is always an investigation. If it's a minor error, the airline does the investigation, the safety team does the investigation. If it's a major error, the NTSB in America, the CAA in the UK, EASA in Europe will do an investigation. They'll do a formal post-incident review. They're looking at what are the contributory factors, not what's the root cause, because there will be many factors that contribute to any incident. And they're asking 3 questions. Did the person do what they were supposed to do? Did the system set them up for success? And did the manager support them correctly? And it requires something called a just culture. And a just culture is something that's brilliant to get in your organization. A just culture is this. It says, if you make a mistake, if you're human, if you're fallible, then that's fine. Nothing bad will happen. If you deliberately broke a control, yeah, something bad will happen. But if you're fallible, and so you get this honesty culture in aviation, which is the heart of aviation safety. People said, yeah, I made a mistake, I'm really sorry. So, okay, you made a mistake. How can we engineer it out, or how can we compensate for it, or how can we reduce it so it doesn't happen again? Can we do that in information security? Damn, yes, we can. There's 2 requirements in DSS, 10.7.3, critical control failure, why did it happen, what are the contributory factors? 12.10.6, oh, we had an incident, can we fix our incident response plan? But with this, did the people do what they were supposed to do? Was the system set up for success? Did the managers do what they were supposed to do? If you're interested in a just culture, I did a presentation at RSA conference back in 2022. You can find it on the internet of the lessons from aviation and how to build a just culture in cybersecurity. It's a 40-minute presentation, so I won't try and recap it in the next 10 seconds. And so I'd like to challenge us all to change from doing cybersecurity to being cybersecure by learning from the aviation or other safety-critical industries. And to wrap that up, there's really the 4 lessons are, number 1, how can we make it sure that a human error doesn't affect anything, and we do that by engineering fallibility out? How can we catch human errors before they have an effect? And we do that by compensating for fallibility. We expect it to happen. We expect when we look at a control for it to fail, not for it to be in place. Often when we look at controls, we're optimistically expecting it to be in place. We expect control failure. How can we improve human performance by reducing fallibility? And then finally, when we have an error or an incident, how can we engineer or compensate or reduce it so that fallibility doesn't create a problem? I hope this has been useful for you. I hope you've had a great 3 days here in Barcelona. And I hope to see you again in Amsterdam. I think it's Amsterdam now next year. Thank you very much.